welcome back to Learning from the Core Practicals. This experiment we're going to be looking at rate of reaction, which is a chemistry practical. So rate of reaction, let's look at the theory first of all and what that means. The rate of a reaction is how quickly a reaction takes place. It can be observed by measuring how quickly the reactants are used up or how quickly the products are formed. So to do that as a calculation, the rate of reaction is the reactant that's used up or the product produced divided by the time it takes for that to happen. Rate of reactions are explained by collision theory. So this is the theory behind rate of reaction. How often reacting particles collide is called collision frequency. The more frequent the successful collisions, the faster the reaction is. The minimum amount of energy that particles need to react is called the activation energy. So all these words in red are the key words that you need to mention when you answer an exam style question about why the rate of reaction is fast or slow. The more frequent the successful collisions, the faster the reaction is. Different factors can affect the rate of a reaction. For example, temperature. Increasing the temperature increases the energy, so there are more frequent collisions. Concentration. When there's a higher concentration, it means there are more particles, and therefore there are more frequent collisions. Pressure. So if the particles are in a smaller container, there are more frequent collisions, because there's a higher chance of them bumping into each other. Smaller solid particles or a higher surface area. So if there's a smaller solid particle, then you're increasing the surface area. And that means particles have more area to react with, and therefore there will be more successful collisions. Okay, so let's look at the practical now, and I'm going to talk you through what the different variables are. This is a really commonly asked practical when it comes to exam questions and exam papers. So we're going to be reacting calcium carbonate or marble chips, and we're going to be reacting it with hydrochloric acid. Okay, so we've got our marble chips, we've got our hydrochloric acid. And we're going to look at the effect of surface area on the reaction rate. Okay, now I want you to already start thinking about how can we change the surface area of our marble chips. Well, what we're going to do is we're going to look at different sizes of marble chips. So we've got large marble chips, we've got smaller marble chips, and we've got powdered marble chips. Now the smaller the size of particle, the larger the surface area. Okay, so remember I was telling you about the effect of surface area on rate of reaction. Have a think, which one of these three do you think you would see the fastest rate of reaction? And the dependent variable, remember that's the variable that we measure, is going to be our reaction rate. Now remember, there are different ways you can measure reaction rate. You can look at the rate that the reactant is used up. So we could look at, for example, the mass of marble chip before and after. Or we could look at the rate that the product is produced. Now the product that's being produced is going to be a gas. So we're going to look at the volume of gas. And there are two ways that you need to know about in order to be able to measure volume of gas. Okay, the one that we're going to use in our method today is using a water trough, so you'll see that throughout our experiment. The other way we could measure volume of gas produced is by using this gas syringe. Okay, now the gas syringe, all it does is it moves out slowly as gas enters the syringe, and it has here the scale on the side so that you can see the milliliters of gas that's released. We're not going to be using the gas syringe method today, but please bear that one in mind. It can be used as a more accurate measurement, and you could be asked about this method in your exam style questions. Now, in any experiment, you need your independent variable, you need your dependent variable, which we have, and we need our control variables. Now remember, control variables are anything that you need to keep the same so that it doesn't affect the results of your experiment. So have a think now, what factors might affect our rate of reaction other than surface area? Because we're changing the surface area. Well, those factors are temperature. So we're going to make sure our temperature is maintained, and it's going to be done at room temperature, all within the same day, so the room's going to be roughly the same temperature. Concentration, so the hydrochloric acid we're using is going to be 0.5 molar, and it will be 0.5 molar throughout the whole experiment. And finally, pressure. So the container that our reaction is going to be happening in is going to be the same size container, and the pressure is not going to be changed. So that's what we're going to do in our experiment. Let's have a look at how that's going to work now. Okay, so let's make sure we've got our start and control variables all the same. We're going to start with our large marble chips, and we're going to weigh them. Okay, so to make sure that we use the same mass each time so that that doesn't affect our results. So the first thing you need to make sure that you do is you zero your mass balance so that you don't include the mass of your plastic cup or whatever you're measuring it in. And we measure the mass, and we want them all to be roughly the same. So this says 6.04. Now with your large chips, it's going to be really hard to get it exact, but we need to make sure that all of the masses are roughly going to be about 6 grams, okay, because this is roughly about 6 grams. The other variable we need to keep the same is our volume of acid and our concentration of acid that we use. Okay, so I'm going to measure out 50 mils of hydrochloric acid. This is hazardous, so I don't want to get it on my hands. If I do, I would either tell my teacher or rinse it off immediately. There we go, there's our 50 mils. And I'm going to add it into our conical flask that's set up ready for us. This is our first reactant, our hydrochloric acid. So we would use 50 mils of the same hydrochloric acid each time. And what I'm going to do is I'm going to set this up ready so that we'll be able to measure the amount of gas released when we do the experiment. So this part is a little bit fiddly, hopefully I can get it first time. So, and I have to be quite quick with it. So I'm going to place this in. And hopefully it should work. See, I've set up the measuring cylinder. It was full of water and I've tipped it upside down and it's now held in place. There's tubing running up into the measuring cylinder, so as gas is released, the water will be displaced and we can measure the volume of gas released. This is quite a fiddly thing to do. It's much easier to do in pairs, so I would work with a partner as you do this. The next step as well, I'm going to have to be really quick. So I'm going to add my calcium carbonate chips into my hydrochloric acid. I'm going to put the stopper on immediately and then start the clock. Every 30 seconds, I'm going to record the volume of gas that has displaced the water. Okay, so I have to be very quick with this. Place it in quickly, the reaction started, put the stopper on, and then start the timer. And every 30 seconds we will measure the gas released. It's important that the stopper's on tight because we don't want any of the gas to escape. That would affect our results. 30 seconds has now passed, 0. You can see the gases being released here, you can see the bubbles coming up, just not enough yet to have displaced any of our water. That was still at 0 after a minute. You can see those bubbles are going, just not very much. This was with our large chips. And that's another 0. So I'm going to pause now. I'm going to continue this for another 4 minutes. Okay, welcome back. So we've completed that same experiment for our large chips. We finished off after 4 minutes. We used our small chips and we completed it for powdered chips. Well, they weren't chips at all, it was just powdered calcium carbonate. Now, there's some quite interesting things that we've seen from our results here. So, to start off with as well, we can see that there was such low volumes of gas released at the beginning here that this is just recorded as 0 because we didn't have a scale small enough. Now, something that you could do to improve that is we could have used a smaller measuring cylinder, and that would improve the accuracy of our results with this. So you could be asked a question about that in your exam. For this reaction here, use a smaller measuring cylinder so we can see a smaller scale for more accurate results. We've got a nice simple set of results for our small chips. And our powdered, the reaction was so fast, it was so very, very fast that after 3 minutes, what happened was 100 mils of gas was produced, but that was after 2.5 and 3 minutes. Now, there is a reason why it seems the reaction has stopped here, and that's not because the reaction rate was slower for any reason. It's actually because the reactants had been completely used up. So if you were to draw this as a graph, what it would look like is it would look something, it would go up very fast and then it would flatten out like this. And that's a typical graph that you would see on a rate of reaction graph, because at this point here where it flattens out, the reactants have been used up. Okay? So I'm going to get rid of that for you. We can see here that there was a very slow reaction with our large chips, a faster reaction with our small chips, and a much faster reaction with our powdered calcium carbonate, which you'd expect to happen because there was a larger surface area.